Welcome to this presentation. I am Abhinav Azad and I'm a final year dual degree student at the Department of Engineering Design, and this is my presentation on my dual degree project which I have pursued under the guidance of Dr. Nirav Patel in the Inspire Lab of IIT Madras. My dual degree project is on virtual reality training module for robotic surgery skill acquisition. Here we have used Kuka IIWA robot and we have created a robotic surgery simulated virtual platform on Unity 3D. Along with that, we have also used 3D Slicer to create an end-to-end pipeline for image-guided robotic surgery setup. The first section, we will answer the basic questions of what this project is all about. So it is very important to understand what neurosurgery is because this platform is meant to train neurosurgeons primarily. Neurosurgery deals with various disorders of brain, spinal cord, spinal column, and peripheral nerves throughout the body. It's also one of the oldest form of surgery practiced in medicine, over 8,000 years old. Indeed, we have a lot of patients who suffers from neurotypical diseases and disorders, and more than half of them, which is around 13.8 million people, who require surgery. Most of these neurological procedures goes through hours of surgery, which includes a comprehensive and very complicated procedures in the operation theater. An example surgery such as removal of a brain tumor can last up to 15 hours. And indeed, there is a high risk due to the complications in the procedure of a neurosurgical operation. Hence, there is a very high fatality risk associated with neurosurgeries. And now we will talk about robot-assisted surgeries, which is a boon, especially when it comes to neurosurgery. It is so because uh, assistance of robots in surgery can bring very high precision as compared to the hand. And a very popular example is the minimally invasive surgery, where robots have proved to be very, very useful. It is also main reason behind high efficiency. Cut, 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 cut. Using robot assistance in surgeries, we can achieve high efficiency and least errors, also leading to very low chances for infection and risks due to very low human intervention during the procedures. Along with that, we also reduce the operational time a lot, which enables the surgery to be very quick and cheaper. Along with that, we also have seen that robot assistance can enable our surgeons to perform parallel tasks during the surgeries. And this is really because the collaborativeness between a human and the robot, which is bringing miraculous improvements in our medicine field. Now let's talk about Kuka IIWA robot. Kuka IIWA, formerly known as Kuka LBR IIWA. As the name suggests, the IIWA word represents here a robot, which is Industrial Intelligent Work Assistant. So this robot was built uh, to have very high accuracy and precision, almost 2% precision under maximum torque, which is incredible. The design of this robot is also very phenomenal and unique as it very cleverly mimics a human hand. So the joints that we have in a human hand is uh, very cleverly mimicked in this robot design. And the combination of rotary and articulated joints corresponds to ball and socket joints of a human shoulder. And we also see that due to the redundant 7 degree of freedom in the robot, we also get something called the redundancy circle, where the robot can achieve infinite number of positions holding uh, a particular coordinate at its end effector. And this is very, very useful for use cases such as surgeries or collaborativeness in an industrial setup. We can see the doctors performing such complicated procedures using a lot of machines and robots. And this is just miraculous and incredible. But these doctors are never taught these skills in medical schools. How will these doctors learn these skills and start using them in the public healthcare? Yeah. So we saw how much we want our healthcare system to modernize, not just in terms of technology, but also in terms of how well we are at learning things, not just as students or teachers, but also as institutions and professionals. So now let's talk about the why. So once we know the need for training our doctors and medical professionals and understanding the risk and unaffordability to train them on real life subjects and real robots, we find out that training on simulation works pretty good and it doesn't cost us much. Training them on real life subjects and using live robots. Of course, it is not very available all across the world. Along with that, um, there's also a lot of chance of mishandling for people who are using it in the beginning. Now, let us see why immersive learning on platforms such as VR is very effective and it can generate almost similar learning results and learning curves as we would in real life. It is simply because of heuristic learning approach, which is learning by doing. Inside of VR, you can simulate a real world, and it is as if you are learning something by doing, and it is the best way to learn something. Along with that, it also induces spatial learning. And embodied cognition. So now you can remember things because you have seen it and you have experienced it virtually. So in our work, we are using Oculus Quest 2 headset, which are essentially head-mounted displays, and it also comes with controllers. So we segmented the skull, and we are using the same skull across two platforms. And with this training module, we propose to train people on doing cross-platform registration using the Kuka IIWA robot. And this is what I was just talking about is doing the registration from 3D Slicer to Unity. And on the left, you can see some basic steps of the registration and planning, which is essentially followed in a typical cross-platform surgical setup. You can see we have like three sections in our UI, which is the startup menu and then the experiments menu, which comes when you click into the start experiment button. And then you have a set of tasks which you can choose. Selecting on any of these tasks, you will be uh, reverted to the main environment where you will have these um, uh, tasks to be performed, and performing these tasks you will be getting instructions, and we will also see it in our demo how it is happening inside the environment. Along with that, we have also tried to add some user experience features which helps our user to do the registration task correctly. And one of the main user experience feature is the collision detection. This is the schematic of the whole system design on Unity, where we are showing all our events management and how we are handling the UI game instructions, and it will give us an overall workflow of the whole Unity um, environment and how we are linking it to from Unity to the 3D slicer. That is how the whole system design works. And the game instructions are also dynamic, which we will shortly see in the in this demo. Let's begin the demo. So here first we can see the UI interface where we can interact, and first we go ahead and give a user ID. We can also take a trial run where we can just go ahead and have a try run over the whole setup. But right now we'll go through the experiment, and here we will just enter a user ID, say 03, and we will take a task. We will take a random task here. So let's take task number 4, and the joystick which I'm using, rolling the robot. And I can switch the camera view, and now I will just try to register these points. When I get close to our object of interest, my tip collides, and this is detected by the change of the color, and we also hear a sound feedback. So when I reach the point, I can press the select button, which is meant to register that point, which also gives a sound feedback, which you can hear. Now I can select the second point, and so on for rest of it. Try to make sure that I'm always on the surface of the skull, using my visual and the sound feedback. And also you can see on the screen, the user is also getting instructions of so I've selected the 15 points. Now the UI is telling me to send these points to 3D Slicer by hitting the space bar. As you can see, I don't have ID number 03 on my list, and to send those points, I just have to hit enter, and with a sound feedback, I can just that after doing you can see I've received the 15 points with the uh, for this point list as ID03 task 4, then the date. And here I have the 4 on how to perform judicial registration, and then choose specialized, and then go to judicial registration as we are here. And then we have to select fixed landmarks. Here we will be using skull 4 point list as our fixed transform, and moving transform would be for our second user performing the task 4. So this red points which we are, let's go ahead and we choose the transform type as similarity, and currently as you can see there is no RMS error. We will get a transformation matrix, and we also will get the error. So here the RMS error is 13.1116, and now we can go to transforms, which is here, and here we can if we select, we can select this transform which we just got out of the registration step, and uh, how it works. So we are just going to transform these red points itself into the coordinate frame of the skull which we see here. So I'm just gonna select these points and go to transform. So now you can see we have approximately uh, registered our points, and these are not very accurate, but we can see that these points are coming very close to each other, and even some points are below the other points. So yeah, that is a basic demo of how we are doing our registration. Now we will see the same demo of the platform in a VR setting. So here, one of our participants, Vishnu from Mechanical Engineering, he's trying out our training module, and he is wearing an Oculus Quest 2 headset and using the Logitech joystick for doing the robotic controls. So he's currently trying to register the points, and you can also see that the screen is also getting updated with the dynamic instructions. With this, we conclude this presentation. Thank you very much for staying back and listening.